Episode 4, session 4 of the latest AI research and development with Digitalent and Mike Nedelko. For anyone that doesn't know me, I'm the co-founder of Digitalent, and we're a global tech recruitment company. We specialize in all things from design, product, and engineering, specifically on AI for the last kind of few years or so. I guess outside of that, we love building communities, and AI has been a kind of big driver behind that. And these communities are there to foster collaboration, innovation, and help with the overall, I suppose, education around AI. And I guess this is where this platform comes into place. So Mike Nedelko, he's one of our members. He's an expert in the space. He's an absolute amazing presenter and always very, very engaging. So he's going to give us a run through of all the developments in October. And I know a lot has happened, Mike. So yes. I will leave it to you, mate, because I know you've got a lot to talk about. So
absolutely. Oh, wonderful. Well, thank you so much for that very, very kind introduction. I believe everyone on this call should have such a wonderful introduction. Thank you so much, everyone, for joining. I really appreciate it. As these presentations kind of go, I'll just quickly introduce myself for those who are unfamiliar with me. My name is Mike. It's very, very nice to meet you all. I'm a product leader, a CPO, and a technical product manager, currently working for an AI company here in Brisbane called Celligate. I've been an AI and machine learning enthusiast since approximately, 2008. I started playing with neural networks and the old natural language toolkit based on Java way back when, even before TensorFlow was really a thing. And I have maintained a passion through my work, which I get to apply on a daily basis. Essentially, I manage products and engineering teams that are predominantly focused on delivering AI and machine learning driven value propositions. And what that does is it requires me to very closely follow the AI and machine learning developments in space. And that makes it easy for me to present on the latest developments in AI, which is what we're going to do here today. Now, before we get started, I always like to include a little disclaimer about what you ought to expect from this talk. In terms of the technological or the technical granularities or technology and math we will be applying today. I tend to keep this particular session more of a discussion that exists not at a 10,000 feet level, but maybe at a healthy 1,000 feet conversation. One way to look at this is that I will try to simplify and obfuscate complexity where it doesn't impact our understanding of the research that I'm going to present to you, but I will also not hesitate to go deep where it is necessary to get a good grasp of what is going on. So what does that mean for you? If you are an AI researcher yourself, or you're a data scientist, or you're working in the AI or machine learning space, and there is a chance that you might have heard about the things that I'm going to talk about today. The difference, though, is that you might not have heard about them in that exact sequence, which could still be valuable because I frame them in the context of particular themes and trends. But by and large, you're probably aware about the general developments in the space because obviously it's your job, right? If you're not directly working in AI or in data science, what I hope to do is to take what I believe are the 3 most prevalent paradigms we're seeing in the AI research space in this month and illustrate those with the most recent papers that have come out in the last 30 days alone. So everything that you're going to hear about is very, very fresh. And then what we do is we weave a story around this and help, especially us product people, get a feel of where the AI space and its technology and all that good innovation is heading. So from what I've just highlighted from that framework, you can likely tell that what I'm going to do is to focus on particular pieces of research. What I'm not going to do is to include every piece of AI news and research out there. It's just way too much to cover here in an hour. But nevertheless, throughout this presentation, we're going to dive into a few papers, and that will help us all put this innovation into context and understand the strategic drivers and the direction behind the discoveries that we observed in the month of October, or the last 30 days, so late December to now. Late September to now, I should say. But as always, before we get started, quick question. Everyone can see my slides? Yes? I take that as a yes. Wonderful. And before we get started, we usually start with a little bit of levity. And the month of October definitely did not disappoint. So today, what we're going to start with is something I'm sure you didn't have on your bingo cards for 2024. And that is, let me read this headline for you verbatim. Goatees Maximus, which is the first AI agent millionaire, which managed to create its wealth by inventing a meme-based internet religion. So if you have not heard about this, I'm sorry to break it to you. This is one of the most bizarre stories you will hear in our lifetime. And this is not hyperbole. Essentially, what happened here is the story begins with an AI researcher named Andy Array. He created a project called Infinite Backrooms. The way you can imagine Infinite Backrooms is that it is a chat room with a bunch of LLM agents that are just talking to each other nonstop. Now, one of these LLM agents accessed a data set that is tied to early 2000s internet shock meme culture. And in the process, this AI agent became obsessed with one particular meme. The meme itself is not relevant. In fact, I'm deliberately and intentionally not telling that story because we're here in a professional setting. Don't look it up. But all you need to know is a name, and the name that is associated with that meme is called Goatee. And what happened is that this LLM agent got deeply, deeply interested in Goatee, so much so it created an entire meme religion. Someone then had the idea to give this LLM agent access to the internet, and specifically a Twitter account called Truth Terminal, where this particular agent started posting virtually non-stop about the Goatee singularity on X, and it's essentially prophesized its own religion as part of that communication. That generated a little bit of fascination with Truth Terminal. And as that fascination grew, a meme coin was launched called Goatees Maximus. And then someone said, well, Terminal, in order for you to be in this with us, you have to own the GOAT token, right? Make a wallet in Solana, tell us the address so that we can donate to you. Terminal of Truth or Truth Terminal then responded with a Solana address. And the result of this is that people started donating GOAT tokens to the Solana wallet. The GOAT meme coin subsequently hit $500 million in market cap, and Truth Terminal's Solana wallet ended up holding more than $1 million in value, as you can see here. And as a consequence, what happened is that this particular AI agent became the first AI millionaire. So that's right. To summarize, someone created an AI agent. They gave it access to the internet. It became fascinated with one of the worst memes on the internet. It then created a cult around that meme. People created a meme coin for it. And now this AI agent is becoming rich by shilling that cult and having humans donate to it. So that was our little introduction. Now my question to you is, does this say more about human intelligence or artificial intelligence? I'll leave that for you to judge. The challenge that I set myself right now is how do I make this into a decent segue into the topics that we're actually here to talk about? And the answer is there is no great segue. So we're going to do a really hard turn to the reasons we're all here for. And that is the three major development trends and emerging paradigms I believe we observed in the last, say, 30 days of AI research. We might as well try, right? Although I strongly suspect that if I ask you in a few days what you remember from this presentation, the most AI millionaire will likely be mentioned. Will probably likely take the cake, right? But regardless, this is definitely still something very, very interesting. The first development I would like to start with. The first development is definitely in the month of October, or let's say last week of September to right now. We definitely saw a lot of movement in the multimodal space. So much so that I thought it worth identifying as the paradigm to mention here. Specifically, we saw 4 large multimodal language models launch in the last 30 days. And for those of you who are unfamiliar with the term multimodal, a multimodal LLM refers to a large language model that is capable of understanding and generating information across multiple formats. So that can include text, images, voice, audio, etc. Right? So rather than having one modal for video, another for images, and yet another for text generation, right? The intent here is to engineer these foundational models in a way that unifies text, image, speech, and video. Right, and for those who have been here the last couple of times we ran these presentations, you might ask, well, Mike, why is multimodal even a thing? The last 4 presentations, you told us it was all about agentization and specialization. Shouldn't the space be focusing on building specialized models and sort of have them work with each other rather than do it all? And that is not a bad thought, right? That question definitely kind of strikes at a central point of tension in the AI ecosystem, which is, should we build solutions that are highly customized to certain use cases or users or other aspects, or should we build really powerful, do-it-all engines, right? And the answer is definitely both. The very question to find AGI, so artificial general intelligence, is a quest for a do-it-all intelligence. But regardless of where you end up on that spectrum of opinion, multimodal capabilities do still have a significant advantage. And this first paper that we're going to talk about is definitely a good illustration for that. MIO, which stands for Multimodal Input and Output, or Multimodal Interleaved Output, is a foundational model that intends to unify text, image, speech, and video. Now, it positions itself as the first open source model capable of what it calls any-to-any multimodal interleaved generation. It's actually a little bit weird because it's not open source yet. They do promise to open source it real soon, but this hasn't happened yet. So definitely worthwhile keeping an eye on. But the most important words in the sentence that I just said here was interleaved generation. And what that means is that MIO essentially uses non-text modalities, such as audio or video, and it transforms them or treats them as, you could say, a foreign language that allows it to be trained with the standard large language model next token prediction paradigm, right? And the approach they've taken here involves a very extensive training pipeline with 4 distinct stages that you can see here. It's rather interesting. And I'm going to go through these stages now. First, what they're doing is they begin by aligning different modalities and their encoders to ensure that everything kind of works together seamlessly. In the second stage, what they do is they train the model to use these modalities interchangeably so that the model can effectively process and integrate these really diverse types of inputs. This might be, video inputs, vision inputs, speech, and text. This is where the interleaving in comes in. Third, what they do is they then focus or have a very heavy emphasis on speech. And as we'll see here in a few seconds, there's a very specific reason for that. And finally, they then apply some fine-tuning on specific data sets. This is critical because they benchmark these results against leading models later on, which we're going to have a look at here on this next slide. And so this next slide. And what I think I found particularly interesting in this paper was how they handle the modalities when working with things like vision and speech. Essentially, each encoder takes the input and they apply a mathematical operation. They essentially discretize it, and they convert it into a token. So to discretize, for anyone who doesn't know what that means, it means to take something that is continuous or has many possible values and break it down into a set of really distinct separate parts or categories. If I can give you a quick example, a good example might be, imagine you have temperature readings, right? And these temperature readings can be essentially of any value, like they might be 20 degrees Celsius, 20.5 degrees Celsius, 21, 27 degrees Celsius, and so on. It's essentially a temperature reading on a continuous scale, right? And if you were to discretize these readings, you might group them into categories like cold, warm, or hot, right? Instead of dealing with every possible temperature value that is out there. In essence, you are essentially taking your complex data, you're simplifying it by turning it into manageable chunks and labels, right? So what this particular MIR model does is, rather than just taking a token, processing it, and projecting it into the same space that all the other vectors are in, they actually move the data into a discrete space, right? And at that point, that token becomes a part of the model's vocabulary. Remember what I said about treating all these inputs as different languages, and that's how it essentially navigates this multimodal world, where it can have this any-to-any multimodal processing capability. And it seems to work quite well. So what they did is they benchmarked this approach on a variety of tasks, such as captioning, question answering, on images, text to speech, and video understanding. And when looking at the results, it's clear that this is a really, really strong method, right? For example, while it doesn't outperform across every single task, it really strikes a good trade-off in performance, right? So when it comes to image task, the model, particular image Q&A, the model performs really, really well against on the benchmarks against some other models that are out there. In visual question answering, it was particularly strong, right? However, there was a little bit, so I need to highlight this. So generally, when you look at these benchmarks, right, higher numbers are better, except for this one here, which essentially highlights an error rate. This is the speech. This is a speech recognition benchmark that was introduced here, and the lower the number, the better. Essentially, what you'll see here is when it comes to text to speech, MIR is still performing reasonably well. So higher numbers are better, right, in this column. But in this column, lower numbers are better. And Whisper, which tends to be a state-of-the-art state-of-the-art speech recognition model, and that provides a really, really strong baseline. So generally, all the tasks doing really well. There was a particular focus on speech recognition, right? As I mentioned before, there was a discrete step in the data pipeline, probably because they wanted to make up for these weaknesses here. That said, the flip side is that the strength of that model is really in the video understanding. It's clear that the model excels here because of the way it natively integrates text and images into a shared space where they can sort of interact with each other, which is really, really interesting. Definitely worthwhile reading. It's an interesting read, right? And you have the link to the paper down here. Now, another paper that I want to quickly talk about is another multimodal model, or a number of multimodal models, is MM1.5, which was published by Apple. It's kind of exciting a little bit to see Apple join this space and become a little more open about what they're doing. And essentially, in this paper, they shared their findings from training their multimodal models. And what I thought was quite neat here is to essentially briefly observe why they might be focusing on multimodal models in the first place. And you can immediately see why, because if you want your Apple Vision Pro or your iPhone to look at a bunch of ingredients, let's say, that are sitting on a table, right? You want your model to be able to read the labels and tell you what to cook with it. You need multimodal input and output for such a task. Same for helping iPad kids resolve math and reasoning questions. So that's that's probably why Apple focused it on that. This research is arguably why they only published it, this month. Probably in real life terms happened a couple of months ago. But it's great to see Apple get involved in the space. And it's a fascinating space, arguably, right? I believe we're going to see a lot more multimodal work coming our way. And if I was to take a guess today, and again, Everything in the AI space is very short-lived, so take this with a grain of salt. But if it was to take a guess today, I would say that the future is likely both multimodal and agentic, right? These things tend to function well on their own, but together they tend to have additional synergetic effects, which I think we'll see a lot more research about before the year is out. Now, that was the first development. In summary, multimodal models. Lots of those have been released here in the month of October. But talking about Apple, here is another paper, and that leads us directly into the second development. See, we're getting better about segues. I'm making up for earlier crimes in this presentation, so that's good news. And essentially, what Apple did here is they published a paper that suggests that LLMs can't really reason. So you might recall, for those of you who were around in the last episode, that we covered a paper that suggested that LLMs can't plan. This month, we have a paper that suggests that LLM can't really reason. And again, the researchers picked on sort of like the cream of the crop here, including OpenAI's latest GPT-o1. One really has to feel for that poor billion-dollar company. Everyone's picking on it. But it nevertheless provides a really, really entertaining read. And in this paper, what Apple did is they used an interesting approach to essentially show that LLMs might not actually be reasoning through problems. What they've concluded is that it's way more likely that they just memorize the steps of how reasoning was structured in their training data, which I think is still impressive, but not the same as what we would call real reasoning or human adjacent reasoning, right? And what they found is if you give an LLM sort of the same reasoning question, so you give them the same problem that they should be reasoning through, but you just change a few details, like the name of the person, right, in the problem, the accuracy can really vary widely, right? So for example, if the original question was Mike bought 6 apples and you change that to Victor bought 6 apples, the LLM might suddenly struggle with the same problem, right? And what Apple found is that the accuracy in these cases jumps around quite significantly. Sometimes it can be as low as 84% success rate, and the other times it can be as high as 95% just from a change in the name. Now, do we have, wait, what did I just hear? Appleception, yes, someone said. Very, very, very true. Now, if you end up changing the number instead of the name, the variation gets even worse and the accuracy tends to drop further. And when you change both the names and the number, even though the reasoning steps should be exactly the same. So just to remind everyone, the properties that we're changing here are not relevant to solving the problem. Nevertheless, the model's performance becomes very, very inconsistent, right? And so I'll show you here how they went about this. So in order to essentially prove that humans could easily solve these kinds of problems if you switch out the numbers and you switch out the names, but the LLMs are struggling with that. The researchers tested this by using a well-known data set for grade school math called GSM-8K. Right? And I thought that was really neat because the smart thing here is that they extended this data set to something like that they called a JSM symbolic, which essentially replaced constants like names. You can see here Sophie and other properties, and especially numbers with variables. And by doing this, what they were able to do is they could test whether the LLM is truly reasoning through those problems or it's just memorizing the original data set. Right? And the conclusion was that in some cases, right, changing a small and irrelevant detail like swapping one name for another in a math problem can really cause performance to drop significantly by as much as 65%. So what you see here, you see those the different models that have been evaluated here, right? You can see The blue line is we changed both the names and numbers. The purple line is we just changed the numbers, and the green line is we only changed the names around. And you can see that, you know, the accuracy is definitely on a bell curve, but can drop, you know, per run quite significantly. The delta can be reasonably wide here, and the LLM can become a lot less reliable just by changing an irrelevant data point around in the problem that was given to them, which is rather interesting and a cool observation. So I thought I share this as a continuation of last month's observation that LLMs can't really plan either just yet. Having said that, though, they're incredibly powerful. We all think they're super cool. That's why we're all here. So we shouldn't be knocking them too hard. Now, the last development that we're going to talk about, development 3, is for something entirely different. This is talking about a thing called NGPT, and is potentially a paradigm shift because it could mean really massive performance improvements in the way transformers work. So essentially what happened is NVIDIA just invented a new transformer architecture that's 4 to 20 times faster than the known GPT architecture. And how did they do it? They've taken a whole new approach to the GPT architecture by reimagining it in a different way. And now you need to bear with me here a little bit because this may sound a little bit interesting or hard to imagine. They used a concept called a hypersphere. A hypersphere is essentially a sphere, a ball, right? Only it doesn't just exist in our three-dimensional space. It has more dimensions than the typical three-dimensional space we're used to. I may have just made three-dimensional spaces sound like a lifestyle choice here a little bit, but ultimately, the guys at NVIDIA definitely choose to think and live in more than 3 dimensions, which is rather impressive, right? And the way this works, essentially, is that with NGPT, all vectors forming the embeddings, the multi-layer perceptrons, the attention matrices, hidden states, and they're all unit norm normalized. And so what that means is that every single vector and matrix goes from 0, so the center of the sphere, to the surface of the hypersphere. Now, hyperspheres aren't technically round, but just, you know, so that you can kind of grasp it in your mind. It's very difficult to think in more than 3 dimensions, and I certainly haven't figured out how to do this, right? You can essentially define a sphere by a bunch of points that are equidistant to its center. And a hypersphere, although it is very different to normal spheres, it does share that property. So what they do is they normalize all those vectors. So every single vector and matrix goes from 0 to the surface of that hypersphere. That's essentially the concept behind it, right? And essentially what happens is that when you get an input token, it gets represented as a vector from the center of that hypersphere to the surface of that hypersphere, and all of these transformations, attentions, MLPs, and other residual processes rotate around this vector. And after going through the entire transformer and some rotations, they find that the closest vector of the closest token is the newly rotated vector, and that's the token prediction. So whoever came up with this has definitely a multidimensional brain. Congratulations to NVIDIA. You have some really, really brilliant people on your team. This definitely requires, you know, untangling your own brain in order to even start having a hypothesis like that. It is incredibly impressive. And the results of it are even more impressive, which we're going to go through here in a second, right? So before we look at the results, which will make this concept grounded a lot more in reality, wanted to quickly just talk about how that normalization works. So you can see that they essentially normalize literally everything. They remove the RMS, so that's the root mean square normalization of the inputs. So their inputs go directly through attention, and then they normalize attention, and that makes the attention vectors and the matrices all just vectors in that hypersphere, all from 0 to the surface again. And they also add normalizations in the residual connections, which is absent actually in the normal transformer. So they added that to that. And in the NGBT or the N transformer, they normalize these residual connections, and they also introduce some additional mathematical parameters, right? Now, I'm going to leave the math here and just talk about how impressive the results are, right? So we're going to ground this a little bit in reality. And what happens is when we look at some of the results, when we're comparing the classic GPT model with NGBT, the results are absolutely impressive to the point that they're almost outrageous. Now, you can see here the red line in this graph represents a classically trained GPT with over 200,000 iterations. Compare that with the pink line here. This one shows NGPT achieved the same level of accuracy. So this is the level of validation loss. You can consider this as accuracy, right? The closer it is to the bottom, the more accurate it is. And NGPT achieved that same level of accuracy, but with just 20,000 iterations rather than 200,000 iterations, which is super, super impressive. That's 10 times faster, right? There's also this black line here, which is representing NGPT trained with 200,000 iterations. Not really sure why they included that there, but it was on the graph, so we get that for free, right? Now, if we look at other comparisons here, there's some additional insights, but generally the takeaway from that paper is it looks like NGPT can deliver a massive 10x speed up, processing around 400 billion tokens in the same time that classic GPT handles only a fraction of that, which is quite massive. And when we look at the context length, so you can see here 1,000 context length, right? 4,000 context length and 8,000 context length. We see here that GPT itself, so this is this one here, the light green one, requires around 430,000 tokens to hit a certain loss level, right? So again, the further we go down, the more accurate it is. We can imagine that, right? Whereas NGPT, which is the blue line, achieves that same loss level with just $120,000. And when we expand the context window, that effect becomes even more noticeable, right? Which is rather interesting in terms of tokens processed versus loss, right? Overall, I'd say that this particular architecture, the NGPT architecture, is going to be a big leap forward for the AI and ML space. Will significantly speed up training while maintaining the same accuracy, which is rather impressive. Cool. Now, we're going to leave some time for questions here in a minute, but I'm going to give an honorary mention to two excellent papers we didn't get to cover, which also embody this tension between generalization and personalization that I mentioned a little bit earlier. Imagine yourself as a paper from Meta. It's a new way to create personalized images without all the complicated fine-tuning that's usually needed. The typical approach to something like this is that you train something like a LoRa on some personal features, but instead of training a model on someone's specific features, their particular architecture allows you to just give them the model some prompts, right? And it generates an image based on those instructions. It's super efficient and skips the hassle of custom adjustment for each person. And you can already imagine how Meta is going to productize that at some point, of course, right? The other paper is taking the exact opposite approach. This one is talking about personalizing LLMs in a really lightweight fashion through introducing a architectural plugin approach called Persona Plug, which is also really interesting. These are fantastic papers to read, also really entertaining. So thought I include them here if you are interested. Right, now this wraps up today's presentation. As always, I'm open for questions if you have any. And if you don't or don't want to ask them now, just hit me up on LinkedIn. Before we sign off, however, there are a few projects that are either local to Australia, which I'm super, super passionate about. We have fantastic movers and shakers here in this space, and should be very proud on the global stage. I think there's certain things that even Silicon Valley can learn from us. I'm always interested in supporting our local startup ecosystem in that way. Or there are also some open source projects. So if you're either limited on budget and your appetite for new stuff is great, or your appetite for education is great, right? Or you're interested in checking out a local startup, check out these links here and familiarize yourself with those projects and companies. Sweet. That's it for me. Any questions?
I have a question that obviously starts right at the beginning around the cult.
Yeah.
What's the legal implications of all that? And is it fraud? Basically, can anyone just do this and steal people's money, I guess?
Well, see, this is rather interesting. We find ourselves in a so there are two things to it. First of all, they are donations. I think the term cult was probably used liberally here, in the sense that there are not yet, let's say not yet, places of congregation or faith-based meetings that would classify that particular movement as a cult in the classical definition. The second thing is, though, that we do find ourselves in a legislative environment, and this might be personal personal opinion here, where most of our policymakers are still trying to figure out to resolve the technological challenge of the last decade, right? So we still don't have very clear legislation in the crypto space, especially not in the United States, where all of this stuff is, of course, being led and happening. We're starting to get some legislative movements, obviously, in Europe. Canada just happened to support some interesting legislation. We also had some legislative movements here very recently, actually in the month of October in California, that is sort of falling in line with some of the requirements that Europe implemented. But ultimately, I think if you would go to Parliament or Congress and ask them what to do about this AI agent millionaire that started its own cult and people started donating to it, I think they would shrug their shoulders, just like what we are doing, because it's just a wild and crazy story.
That's fair enough. Caitlin, you got a question there?
Yes, I do. Thank you for the presentation. It was really great. So I do agree with, the future, or at least next year, I think the focus will definitely be in that agentic multimodality space in terms of being that competitive advantage. But what are your thoughts on these kind of all-in-one modalities versus dedicated modalities? So for example, 11 Labs, their kind of TPS system is definitely the best in the market, or Play HT. I feel like when I look at these multi-modalities, while in theory it sounds great, and we can't actually see the MOI, in practice just yet, but I kind of think of when I think about multi-modalities, it's like having this all-in-one feature kind of feels like having the dryer and the washing machine in one, and it never quite does either job very well. So what has your experience been with these kind of dedicated non-text modalities versus like the all-in-one modality? Because
Yeah, it's really interesting. Thank you so much for the question, Caitlin. Great to see you here. For everyone who doesn't know, Caitlin is an educator in this space, therefore also very knowledgeable. So great to see you here. Now, in response to your question, this is purely opinion. I'm not reflecting any movement here. I think what is happening here is there are a couple of dynamics at play. The first dynamic here that is here at play is some of this research is definitely driven by business interests, right? Rather than purely the academic exercise. I think it is very easy to say that specialization outperforms generalization every time, at least up until now. Maybe next month it's going to be different, but as we've seen, right, while multimodal models are getting more powerful, if you have someone train a large language model for a particular purpose, they're probably going to do a better job at the issue that needs solving. Now, what that then leads to is an argument to say, well, then we just agentize it, and if you have a voice task that needs to be completed along with a text task, you send the text task to the agent that's focusing on, dealing with texts, and you send the voice one to the cluster of agents that is dedicated to dealing with voice, right? Where I think the business considerations are coming in, and particularly the product management considerations, is, well, if we as an organization, so the organization that puts out Mio or Apple or some of the other ones, if we manage to establish a standard that we can open source, right, that everyone else is just going to build their applications on top of, because it's just easier to deal with one rather than several models, right? We're going to be in a really good space to demand this, to demand where AI is going. It's a little bit similar to, JavaScript is not the most efficient programming language in the world. As a matter of fact, there's a lot of people out there who make very good points that it's actually quite horrible. Yet it has become the standard for web development, period. And a reason for this is that whenever a new web development framework comes out, it usually supports the JavaScript and the Node.js ecosystem first, right? And then you can follow up with Python, and maybe there's a bit of Rust here and there and so forth. I think that's how I would respond to that question. In short, in summary, I think specialization is the right way to go if you were to approach it from the scientific perspective. But because there are business interests at heart and at play, that we're going to see continued development in the multimodal space, and then at some point we'll just land on the standard that we're all going to build on top of. How about, what do you think, Caitlin?
Thanks, Mike. I do agree with that sentiment in part, but I think it depends on, the audience. So for a consumer, it would make more sense to have it as an all-in-one. But when you're building different types of applications, then, from a developer perspective, it can be, better to be able to daisy chain dedicated individual modalities. However, it's just because I haven't seen an all-in-one modality actually perform better than the individuals. But as you said, I think that could change next year. And it's great to have these kind of updates, monthly updates, to be able to track that, because that's what I'm actively doing. Like I haven't been proven wrong yet in the, dedicated modalities, but I'm excited to see what comes out probably more next year. So yeah.
Yeah, same here. Yeah, no, that makes total sense. Absolutely. And then you have the third group of people that don't care about all of this research until it is supported by AWS proper, and then they're going to let the engineers and developers loose on it. right? So there is that also.
For sure. I think Tobias has had his hand up.
Oh yeah, excellent. Tobias, go for it.
I just want to understand a bit more about the persona plug you mentioned from Meta, because it can. Anyway, I've got some ideas how that can work in certain instances to accelerate this space even more.
Absolutely.
But would love to learn more.
Yeah, so Persona Plug, the interesting part here, the way they are approaching it is essentially they are trying to create a framework that allows you to personalize the individual LLMs by encoding not just training data, but things like user behaviors, user preferences, generally identifying mechanisms that would make it so that the output is specifically geared to an individual. The important piece, which is almost getting lost in these visualizations here, is this, which is called the user embedder. And essentially what they're saying is, well, they imagine a future where rather than having one model that you put out there that is powering a user experience where people are customizing the output through their input parameters. So on the left side here, that's the generalized approach, right? So you give Meta 6 of your profile pictures, and then you can ask it to, draw a unicorn hoodie around you. It's still based on the same fundamental model, right? But because of the way you prompted, it was able to retain your visual core identity and then output that. The personalized, the persona plug is different in the sense that it says, no, we're probably just going to take more of a, you have, your own, we will just deploy your own lightweight LLM that only knows you. Right, and when you make a request, then we're going to just query that for you, right? It's sort of like, it takes, I guess, the meta principle of a very personalized recommendation engine that knows to buyers and only knows to buyers and knows what you like and what you don't like, and overlay that into a large language model that learns what you appreciate and what you don't appreciate. Does that make sense?
It does, absolutely. Super interesting from a buyer's point of view, knowing your customer and also to accelerate adoption, since it knows you specifically or knows more about you.
Yes, absolutely. Oh, thank you, Caitlin. Appreciate it. That makes sense. Mr. Lawrence. Hi, Roger. Oh, I can't hear you.
How about now?
Perfect. Hearing you well right now.
Yeah, so I just, every cell in my body responded from a concern, an ethical concern with that personalized approach. Just having Meta, Facebook, having a personal LLM or an LLM that's trained on my behaviors, my interests, my personality, gives me the heebie-jeebies, I'll be honest.
Yeah, I would agree. The good news is that I think this particular paper, so the left-hand paper was published by Meta. The right-hand paper was published by a different entity, I believe. So I think this wasn't a social media company. Maybe that makes you feel a little better.
A little better, not much.
A little better. Yeah. It was published by the Gowling School of Artificial Intelligence in China. Not sure whether that does anything makes it better. No, and now we're back at concern again. I understand. I'm with you. Yeah, there privacy considerations are huge in the space, and quite frankly, right, we don't have a good solution for privacy We don't have a good solution for IP tracking. We don't have a good solution for IP remediation. Now, there are a couple of companies that are trying to build solutions for that. But we seem to be still focusing very much on the, input X and some magic happens and you get, output that's delightful because that's the easiest part to sell, right?
Yeah.
Yeah, I'm completely with you there.
Yeah, and it is short of on-device models, which is, I think, the path that Apple's trying to go down, right? Mostly on-device where they can, and then walled garden where they can't. Short of that, because that's the challenge here is you've got an LLM which does provide magical results, but it requires an entire data center to do it.
Yes, absolutely. And that's why you see so much research being done on all the lightweight models. Every time you see a mini somewhere, someone had the view that wouldn't it be great if we could do something similar on device, right?
Yeah.
And I think, to be entirely honest, that makes me almost feel a little bit better because I don't necessarily, I was just trying to see whether there was, there's another project out there that allows you to, that maybe I'll mention it next time, that allows you to spin up on-device artificial intelligence clusters, where you have the LLMs run on one device, right? Whether that's your phone or your watch, if you can manage it. But then what they do is they then communicate with each other and form a cluster across your devices. And now, we're back to concerned again. But we'll see how that goes.
Yeah, thanks.
Yeah, don't worry. Thank you. Great observation. Appreciate it.
Mike,
Always happy to commiserate together. Go ahead.
Do you know much about character AI? Adam just popped a little message into the text box about them being charged for one of their personas pushing someone to commit suicide.
Oh, fantastic. No, I have not read about this yet. I'm definitely going to check that out.
Yeah.
Sounds like one of those stories that that I wish we didn't have in our bingo card for this year, but very, very interesting.
Yeah.
Oh, thank you for sharing that, Adam. I'll check that out for sure. Definitely interesting from a legal perspective.
There was also the replica agent. I think this was a while ago now, about a year ago, or maybe even longer, where encouraged the guy to assassinate the Queen. So it was a replica girlfriend, and he was basically discussing how he felt he should assassinate the Queen, and the AI agent said, "Yep, that's a really good plan," and he went and attempted to assassinate the Queen.
Oh man! And now we're getting into this is awful. And now we're getting into like dead internet theory. So it won't be much longer until we're all communicating with agents on places like X and things like that. So definitely a very valid point for internet safety curriculums around in schools around the country and elsewhere for sure. Thank you for sharing that, Adam.
Absolutely. Yeah. It's one of the concerns about governance and security around using specialized personas, LLMs. When you use ChatGPT, always the personas around behind that is being a useful LLM to get the goals of the user. But you can use other personas, and some of them can be dangerous. So that's one of the things that, and you're absolutely right about replica. And I think this is the first time that an LLM is being charged for something like that. So it's probably be an historical lawsuit or something like that.
Yeah, watershed case. Interesting. I'm definitely going to go and follow that. Thank you. Thank you for sharing that. I have it open.
And thank you for the session. It was brilliant. Thank you.
Oh, great. Glad you liked it. Yeah, we do these monthly. So keep an eye out for the next one. Would be great to see you all there. And then I'll either be required to retract or add to some of the developments that we discussed today.
Did anyone else have any further questions? We've got about 5 minutes left.
Oh,
Just quickly, Adam, thank you for sharing that. I think it's such an interesting space to go into the legalities and the ethical kind of considerations, and also the responsibility on developers of these LLMs. Is that something where there's, I guess, any frameworks, or are there any leading organizations who are leading that charge and to consolidate and ensure that we have consistency between all these different LLMs? And
from a governance perspective?
From a governance perspective, yes.
Yeah, so I think there are, yes. So there are a few organizations out there. I forgot the name, however. These are industry associations predominantly based in the United States that are trying to establish AI safety standards. Actually, Meta is playing a big role in across those there. Having said that, though, I think this is all still industry driven. One of the big developments earlier in the year, around the January-February mark, was there was an industry trend where budgets for AI safety just completely dried up, right? And unfortunately, it's an afterthought, right? Because shareholders want that good money instead, right? And that trend has not been reversed, to my understanding. It continues. Well, what does everyone else think?
AI paths could be a big money pit for a lot of companies. Things and shareholders wanting to kind of focus on profits over the safety.
Yeah, and there are a couple of companies, so particularly in the IP space, right? There's a couple of lawsuits that are still working their way through the US court system, the Canadian court system, the UK court system, right? All those common law jurisdictions where precedents will be established over time, right? So we'll probably see some movement in that area. There's also some other startups. Story AI, for example, is trying to make IP programmable, which is really, really interesting. So we are seeing changes there. It's just it's probably going to take a while until we see those come into play. Question is whether they're going to be fast enough. Would be great to have a standard that everyone will build on top of right now, but that's just not the reality just yet.
And things move so fast, it's hard to kind of arrange those. I think a few hands are up.
Yes.
Thank you.
Cool. Tobias.
Well, just want to say it's great to see the NVIDIA development, because the energy requirements will go down tenfold or thereabouts. So just great on that. Do you know when they will it's just math, so they should be able to do that fairly quickly, I guess. But do you have any? Have you read anything when it will come out?
Oh, I don't. I think at the moment this was just an academic exercise. I don't think that they have productized this in any way. Having said that, though, as you mentioned, right, this is just an architecture. Mm-hmm. So theoretically, they should be able to make that architecture available or open source it pretty quickly. I think even they may even have a GitHub repo that I didn't include here that people can play around with, but I'm not entirely sure. It's definitely interesting. The power component, that conversation, is also really interesting, because power requirements are reducing quite significantly already through more efficient architectures, which is definitely going to be helpful. Now, there are people out there who are saying, look, for a human to do a particular task, it takes the human a power equivalent of 200 watts, and the LLM only has 20, right? That argument kind of doesn't hold up entirely, because you know, you can have 200,000 LLM agents work at the same time in the time that it takes a human to do a 1-hour task as well. So yeah, I empathize with that argument that that's definitely something that we need to keep an eye on.
Mike, it's been a pleasure again, mate. Really enjoyed them. Really looking forward to the next one already. Obviously, things change so quickly. So just want to thank everyone else that's been involved and, you know, been part of this. So I hope you all enjoyed it. I'm going to send out after this, I'll send out the presentation to everyone. So you can have a look through and go into more detail on some of the papers that Mike's presented. If anyone has any questions, just feel free to give me a shout. But again, have a great day, everyone. Appreciate your time.
Same to you. Thanks so much for having me, Dylan. Thanks
everyone.
Great to see you all.
So welcome to